Okay, so we're going to continue on in Module 1, and we're going to look specifically at, actually, I'm going to put my chat box over here. And I have two screens today, so that's kind of nice. So we're going to continue on in Module 1, but we're going to shift gears and we're going to go to a different chapter. So in Part 2 here, you're going to notice that we are going to be focusing on Chapter 4. Now, I don't know why the book does this, but I just kind of look at their order and it's just a little confusing to me. In Chapter 1, they introduce kinematic diagrams. And then in Chapter 2, they kind of go off on a software that nobody uses, which is okay. The book is technically 12 years old. Chapter 3, they talk about vectors. And then Chapter 4, they come back to displacements. And I'm like, we're in the groove of making the drawings and we need the drawings for position and displacement. So I kind of take it upon myself to, instead of doing chapters, in the order that they have it, I kind of do them in a little bit of my own order. So I just feel like this makes a little bit more sense. So that's why we're skipping over. We will come back to Chapter 3, but we won't be doing Chapter 2, just so that you know. So the PowerPoint here for Chapter 4 is there for us. In Chapter 4, we are not going to be covering each and every section, and I'll talk about that as we hit those and which ones we're going to skip over. So make sure that you're paying attention to the sections that we're going to be going over, or the sections that are in the PowerPoint that will then be what you're responsible for. We won't be, doing each and every one. And then you'll notice that there's a handout here. We'll reference this when we start looking towards the end at the homework. I don't even know if we're going to get a chance to look at these today. Now, before we get into the PowerPoint, let's just take a quick peek at our practice problems for 1B. So I'm going to click on the practice problems here. And we are going to be doing together examples for 1, 2, 6, 7, and 11. Okay, we are not going to be getting all the way through this lecture and all the way through this chapter today. So do not hand in any practice problems. Okay, don't even work ahead, because I had a couple people do that and I had to give them zeros on the last assignment or the last practice problems because they assumed they knew what they were doing and they weren't. And so I just remember, practice problems is a 1 submission deal. It's either a 0 or a 10. So if you're not following the formatting that I'm going over when I do these and demonstrate them fully in class, then you simply aren't going to get the points. Okay. So so make sure that I don't want to see any practice problems for 1B over the weekend, because again, we're not going to get through all these today. So I want you to wait until we've gone through them all, so you have all the information you need and you can maximize the number of points that you're going to gain. So so these are going to be what we're going to be working on. Additionally, I always want the answer to these couple questions, and these are similar to the last ones. They're going to change up a little bit here and there, but this is what we've got going on for this one. So we'll revisit this once we get done with our lecture, but that's going to be the problems that we're going to be doing, which are example problems we're going to be going over. And then our assignment part 2 is going to be the end of the chapter problems that I have assigned here. And again, please do not even start attempting these until we've gone through the practice problems and we've gone over them, and we're not going to be there just yet. Okay. So I know you're eager to get ahead on things. I understand it's fun to work on that stuff and get it behind you, but there is work that I want to make sure that we do, because sometimes you don't, unfortunately, you think you're getting ahead, but you're not being efficient. So, so I just want to point that out. Okay, so let's open up our PowerPoint presentation. And this is going to be our guide through our chapter. So Chapter 4, position analysis. This actually starts on page, I've got to get it open myself, to Chapter 4. This starts on page 72. So again, we're skipping a couple chapters. We'll go back to one of them, but we're here in Chapter 4 for this module. So the objectives of this chapter are basically to define position and displacement of a point on a mechanism. We want to determine the position of all the links in a mechanism as a driver link is displaced. So what we're going to do now is, in Chapter 1, we just looked at if you would, a snapshot in time of where a mechanism was, and we drew the kinematic diagram for that. Now what we're going to do is we know these mechanisms are going to move. We want to now start moving the driving link around and seeing what happens to the rest of the mechanism. Like, how does it affect the position of a slider or or something that's going to oscillate? So, so those are the types of things that we're going to do. We're going to take what we learned in chapter 1 to the next level. Okay. We're also going to determine the position of all the links on a mechanism through an entire cycle of a mechanism motion. So if we have that crank going around 360 degrees, what's happening every 5 degrees, every 10 degrees, whatever it might be. We also are going to be determining the limiting positions of a mechanism. You might have heard of the terminology of stroke. What is the stroke of a cylinder? That is what we're doing. We're trying to find what is the highest and lowest point, or what is the furthest and the closest point that particular, end result or that output from that mechanism is going to create. And then we're going to be looking at plotting a displacement diagram. And again, that'll be towards the very end of our discussion. So starting in section 4.1, the purpose of kinematic analysis, as we know, is to determine the location of all the links as the driving link of a mechanism is moved through or to another position. So if we're starting with, if you would, a home position, like here we are in space, now we just want to move that driving link and see how everything else is going to be affected. Now, kinematic analysis can determine the full motion, determine position, determine the extent or the range of motion. Again, that's like that stroke type of thing. But then also another important aspect is going to be that it determines the spatial requirements. So when we start moving these things around, something that we very often are concerned about is if we are going to have any interference with outside elements. So kinematics, our kinematic analysis does a lot. And again, it's it's the very first steps that we're taking in the design process. I like to call it, again, you've heard me say this, layout work. Okay. So let's talk position first. Position of a point on a mechanism is going to be where it's located in space. So it's spatial location of that point. The primary goal of position analysis is to determine the location of points on a mechanism relative to that crank or that driver moving to a new position. Okay. Now, displacement is going to be the end product of motion. So when we have linear displacement, this is when we have straight line distance between the starting and the ending position of a point. So when we have a slider, that is going to exhibit linear displacement or linear motion. When we have angular displacement, that's going to be something that is like a link that is rotating about a fixed center. So this is going to be the angular distance between two configurations of a rotating link. It is the difference between the starting and the ending angle position. So if we look at the bottom of page 73 and we look at figure 4.4, so it's right down here, okay? Linear displacement is usually a little bit easier to kind of, comprehend or get a good handle on, but this is angular displacement. So if this is if this gray one is the first position or the home position, and we rotate this an angle, we want to know what is the displacement between the original angle and now where the new position is, okay? You'll notice that there is a triangle in front of the angle symbol. So we've got a delta, theta. So delta is the triangle. Theta is a very common designation for an angle. So when we have delta in front of anything, whether it's an angle or a distance, it means displacement, or how, what was the difference between an original position and then a current position. Okay. So delta is always going to be displacement. And then we see here theta being used as an angle designation. Looking at displacement graphical analysis. So in sections 4.4 and 4.5, we're looking at graphical analysis. Now, I want to let you know that this is a pretty long chapter, and this chapter takes kinematics, and it breaks it into two ways of handling all problems. The first way is always going to be the graphical method. So graphical just means that we're going to be drawing it out, moving it around, and then we're going to be measuring the end result or dimensioning it. And we are going to be using AutoCAD as our tool for that, okay? It lends itself well because it's in a 2D space. We really don't need 3 dimensions. And as I've said earlier, it's nice to revisit AutoCAD because I'm going to tell you, even though, yes, the main software of a lot of companies is going to be the 3D parametric, but you'll notice that almost every company is going to have older drawings or different things that they do using AutoCAD because it still is one of the best tools for certain things. And one of those certain things is 2D drafting. So kinematic analysis is all in a 2D form. So that's why we end up using it. So it gets us back into that and good practice. Additionally, the reason that we do the graphical only is because you guys get a lot of calculations in math in a lot of different classes. So in your physics class, in your calculus class, in statics, in strength of materials, and we only have 8 weeks, so we can only do so much. I don't want to drive you guys crazy and have you pulling your hair out, but we get enough of that in other places. So instead of doing everything calculation manual, we're just gonna focus on the graphical and see how everything goes together. So so that's why when we go through the chapter, make sure that we're always paying attention to which examples, which sections, because we are going to focus on the graphical and we're going to kind of skip over I'm going to call it the analytical, but really that's the math that you would do to match those two up. Now, when we go through the graphical analysis, the process that we're going to take is going to be as follows. Number 1, we're going to always draw a kinematic diagram of that mechanism. So we aren't going to forget or go away from what we had learned in chapter 1. Then we're going to calculate our degrees of freedom. That sounds familiar. And that's always a nice check to be sure, number 1, that we have what we need. So typically we know how many degrees of freedom we have for a mechanism before we even calculate it. But the calculation verifies that we have appropriately identified enough links and joints. Okay. And if you don't get the number that you're expecting, then it's worth going back and trying to figure out how come I didn't, like what's missing or did I do something wrong? Then number 3 is we're going to move that driver link to a desired position. So depending on, what you're interested in, it might be, I'm going to move it 30 degrees clockwise, or I'm going to, I'm going to go, 90 degrees from where I'm at. And then we're going to then kind of catch the rest of the links in that mechanism up. They call them slave links because the driver is what is really controlling how everything else is going to move. So let's look at figure 4.5 and the other ones that they have here as well. So I'm gonna go underneath my camera. This is on page 74. And in the middle of the first column, we see this diagram. So this diagram is a very simple 4-bar mechanism. You'll notice that we have our frame identified as number 1. Number 2 is going to be the driving link. Number 3 is going to be the connecting rod or coupler in this case. And number 4 is going to be, it's going to be an oscillating output link. So this is where we're going to start to see that our numbering is going to start to kind of go in that order that I had expressed. We had seen a little bit of the book doing its, kind of mixing things up at times, but number 1 will always be the frame, no matter what. Number 2, which is the first link after number 1, is going to be our input link, where we're going to be putting the work in, what we have control over. That a lot of times is, either called the driver or the crank. And then we're going to have our coupling. That's going to be number 3. And then our output is going to be number 4. Okay. Now that we have our kinematic diagram identified, we want to move this driver link. So number 2 is our driver, our crank. And you'll notice that it's moving that link 15 degrees. Okay. From where its original position or home position was. So we're going 15 degrees clockwise. All right. And now in this position, notice that this new position of B is called B prime, okay? And B prime needs to then be connected to the coupler. So the next job then, once we move our driver where we want it to go, we now want to add on the rest of the links. So if we go over to figure 4.9 on page 75, right down here at the bottom of the second column, you'll notice here was that 15-degree move. Here's B prime for the new position. Notice that it is constrained that it can only rotate about this fixed point of A on the frame. So it can only move whatever its radius is, in, if you would, a full circle potentially. So it moved 15 degrees along, so it moved. And then what we do is we look at, well, what are the other links going to be held to in terms of what their motion will be. So we'll notice that our output link number 4, this one is going to only be able to go along that link, okay, or along that path, that radius. Looking, yeah, can only go along that radius. So C will only move along there. But then we've got this coupler link, which is B to C. So now we know the length of B to C. We don't have the number there, but what we could do is at the end of B, we would start this as our point of rotation, and we could draw a circle with a radius equal to the length of BC, or length number 3, and we would then strike that arc, okay, if you would, for an intersection of that new position for where C prime would be. And I believe that's what we end up seeing on the next page, at the top of the next page. So here is that arc. That is the distance of B to C, or the length of link number 3. And where that intersects, you would finish up this drawing or finish up this link, and you would draw a new one in there. And that would be the new position of link number 4, with C prime being the new position of where that actually is at. And then you would measure, okay, how far was that angle? I wish they would have finished this up, but they didn't in the illustration. But that's really the process we're going to go through. We're going to move our driver, and then we are going to see what happens with the rest of the links. That's going to be the goal of what we're going to be doing in this chapter. Let's look at example 4.1. Okay, example 4.1. Example 4.1 starts on the bottom of page 76. And the process that we're going to go through is we are going to be drawing the kinematic diagram and calculate its mobility of exactly where it is right now. Then what we're going to do is we are going to graphically move the driver length 30 degrees. And we'll see that when we look at the illustration. Okay, you're going to notice here that we're going to strike some arcs on the links and then rotate about any fixed centers that we have. We're going to be using CAD to get the lines of action for which they're going to be going on, because we're going to have a slider to deal with, and then we're going to be striking some more striking some more arcs, and then drawing the new position of the links where the intersections occur. Okay, just going to peek ahead here. Yeah. So let's go underneath and get started here. Now, if you plan to follow along with me today, I am going to be using AutoCAD. So if you wanted to open up AutoCAD and open up your kinematic start file, we will be we'll be utilizing that. Okay, so example problem 4.1, the figure, this is down below here. Okay, this is going to be the figure we're going to deal with. Shows the kinematic diagram for a mechanism that is driven by link number 2. Graphically reposition the links of the mechanism as link number 2 is displaced 30 degrees counterclockwise. Determine the resulting angular displacement of link 4 and the linear displacement of point E. So in this case, all we want to do is we want to duplicate what we see here in terms of the kinematic diagram. So I'm gonna zoom in here, okay? So they're not having us draw it from an existing machine. So this one, we just want to create this in AutoCAD using all the dimensions that are here, okay? So this is a great exercise. This is our first one where we're actually going to be using and looking at, okay, here's our home position. Now we want to use all those dimensions and draw it to scale. So I'm going to go over to AutoCAD. And I do have my start file already set. Now, before I replace this with the name of this example, I'm going to go back underneath here. Right now, we're equipped to make a current kinematic diagram, okay, with what we have there. But you're going to notice when we go up here, and I'm going to go down here. When we move to our final positions, we're going to have to be able to see what our original position was, or our home position of our mechanism, and what the new position was. Now, this can be accomplished a couple of different ways. It looks like what they did is they probably changed the color this is an AutoCAD screen. But what I want you guys to do instead is to change not only color, but also the line type. So we are going to draw the new position with a hidden line type. That way we can see that it's, that it's a different mechanism altogether. So what we're going to do is we're going to go back to AutoCAD and we're going to add another line or another layer so that we can add a second type of a line here. So we're going to go to layer properties. Now you can call this line whatever you want. If you want to call it hidden, you could, but I'm actually going to call it object 2. Okay, object 2. So it's basically just another object line. And I'm going to put it on the green color. Okay. And I'm going to change the line type to hidden. So I need to load the hidden. No, don't do dashed. Hidden line type. Select it. And then hit OK. And it changed it to the hidden. You can leave the line weight the exact same as it was for the object line. All we want to do is have another version so that we can use the object line, the continuous white for the home position, and then the dashed lines or the green, like hidden, as our new position. So now what I want to do before I do this, change the settings, I'm going to add, I'm just going to resave. I'm sorry, not save as. I just want to save as my kinematic start file, because now when I look at my layers, I have that extra layer in there. Okay. So anything that you want to do, to make this easier for yourself, in that kinematic start file is really helpful. So just adding that second layer now, I don't have to worry about it for, going forward or adding it each time. Now I'm ready to do a file save as, and this is going to be example 4_1. There we go. Okay. All right. And now what we're going to do is we're just going to make that kinematic diagram. So I am going to use at the bottom of page 76, the home position right here. So I'm going to need 2 frame members, and I'm going to need 1 slider. Okay. So I'm gonna start here at my A, go back over here, and I'm gonna move. Now, I use a lot of quick commands on my keyboard. So M, enter. Now the space bar is also an enter key for AutoCAD. So if you do M space bar, okay, and that's what I do, M space bar, it goes into the move command. Okay, that's one way that I am more efficient when, and that's what I do like about AutoCAD is I've used it for many, many years. It was the first software that I used out in industry, and the quick commands have always remained the same all the way through, even though the environment has changed a lot and the ribbon, is different. That's something that quick commands, they have kept all of these years. So M enter or M spacebar, because spacebar is your enter key, you can get into the move command as a shortcut. And then what you're going to do is you want to select the objects, and I just want to put, and this is a click, click, not a click drag, it's a click, click, and down and to the right means that anything inside of my box is going to be, selected. If it's not fully inside that box, it won't. Then you hit enter for the items that you selected, and then it's asking you for a base point. Something about AutoCAD that I'm always going to tell you, if you're not sure what to do, look at your command line, which is down here. It'll always be asking you what you want or telling you. So it says specify the base point. So I'm just going to put the base point here, and I'm going to turn off my ortho. So I'm going to toggle that off, and I'm going to bring that, panning is the middle mouse button. I'm going to maybe go over here. I don't really know spatially where I'm at. So it's going to be my first one. Now what I'm going to do is I'm going to draw my first link on object 1 layer, and it's going to go from the center. So I'm going to go shift right mouse button. This gets me all of my object snaps. Okay. Now, a couple of things about object snaps. Down here, you're going to notice that you have the opportunity to put on some running object snaps. So if you go to the arrow that's down next to it, these are all your running object snaps, meaning it's always going to look for whatever you have checked here. So the ones that I have checked, and you can, choose whatever ones you want. You can do all of them if you want, or you can just do select ones. The ones I find most handy are going to be endpoint, center, quadrant, intersection, extension, and perpendicular. Actually, extension I really don't use at all, in quadrant I don't use, but the other ones I do. And then I'm going to click outside of that. So those are the ones that if I'm doing any command, if I'm trying to, like I said, the line command, if it goes here, it's going to maybe go right to either the endpoint or the center. Or you can do shift right mouse button, and this will have all of your object snaps on. And what this does then is it like focuses only on what you specify here. So you can have your running object snaps on, but then this like overrides that. Like if you say, nope, I don't want all of those active at one time in this one part of my command, I just want it to focus on finding centers. So I can select that there. The other way that you can do this, and again, all these softwares, you can do things about a million different ways. If you don't have this menu bar up, you want to go to the down arrow up on the very top. You're going to go down, and you are going to make sure down at the bottom here, if it says show menu bar, click on that. Okay. And this extra layer of menus is going to come up. Okay. Once you have that, you're going to go to tools, toolbars. I'm not clicking yet. And then AutoCAD. I'm still not clicking. Okay. And down here, there's one that says object snaps. Okay. You can pull the object snaps toolbar out. And now here are the icons for all of those object snaps. Okay. So you can still have your running object snaps going, but if you want to focus just on endpoints, you can click it up here rather than doing shift right mouse button. So it's totally up to you, whatever the preference is that you have. Okay. So any questions about that? Yes, this show. Oh, no, I don't, Aaron. Aaron, I just saw your message. I'm sorry. Look up on the top here somewhere. I know the Mac. There is there is that AutoCAD version of, I'm sorry, I don't know where that is. You're going to want to kind of peek for that. The other thing that you probably can do is in the command line, do toolbars. I wonder if that's going to get you. Here's toolbars. So you should be able to, now this is more than what's on that one there. We want to go to object snaps, A, B, C, and O. Object, no. Oh, these aren't, I'm sorry, these are customized user interface. This is not like the toolbars, the AutoCAD tool. Oh, well, maybe if we put in, I'm gonna try this. No, it's not gonna do it. I don't know how to get it added except by doing the tools up here. You might have to do a little bit of research on that, Aaron. I hope you can find it. Okay. So now what I'm going to do is I'm going to do the line command, and I'm going to do shift right mouse button, and I'm going to go to the center. Okay. And I want to go straight up. This is a vertical line. So I'm going to put in my ortho, and then I'm not going to snap to the end, but I am going to input, this is called that dynamic input, a value of 3, enter. Okay. And then my line is drawn to 3. There we go. Okay. All right. Now you're going to notice that we're going to have to kind of construct this. If we go back underneath, we can see that we can't just go to the end of the line here. We know that it's 4.9 long, but we don't know what angle it is. But what we are given is where this frame is located. Frame point is located at D, and how long link number 4 is. And we know that it is 5.3 over and 3.2 up. So we are going to go back to AutoCAD. And what I'm going to do is I'm going to offset a line. Now, offset, you can just key in, or the offset command is up here on the modify. I'm going to use the offset command, and I'm going to offset 5.3 inches, the distance to offset. Now I'm going to select my current line here, and then I'm going to go over to the right, and I'm going to left click. Okay, and then I'm going to hit escape to get out of that command. Then what I'm going to do is I'm going to do a line at the end here, and I'm just going to make it an arbitrary length long. This is a little bit of construction that we're doing, and this is 2D AutoCAD, what you got to do. And then I'm going to do another offset, and this distance is going to be the 3.2. And I'm going to offset this line up that distance. Okay. Now it didn't come, they didn't intersect. So I just want to do an extend, or you can go underneath trim. Extend is here. And I want to extend this line up to there. That is going to be the center. So all I did was I went over 5.3 and up. So this intersection right here is where the center of my new frame member is going to be. So I am going to do a copy of this frame. So the copy command is right here in modify. I'm going to put a window around it, enter. My base position is going to be the center. And I am going to turn off my ortho, and I am going to place it at the intersection or endpoint up here. Okay. So this is that 5.3 over and 3.2 up from where it's at right now. And now what I can do is I can get rid of, and I'm erasing those construction lines. Okay. Let's go back. So I've got this in here. I've got my new location here. Now, again, I don't know the angle that this is at, but I know that it's 3.3 inches long, right? That radius. And I know that this radius is 4.9 inches long. So what I'm going to do is I'm going to draw 2 circles. I'll show you. I'm going to go back to AutoCAD. My first circle, I'm going to do the circle radius, and I'm going to go at the center right here. The radius, so notice that this is the radius dimension. That radius is going to be 3.3 inches. Enter. Okay. Now, that means that from that center out along this path somewhere is where that endpoint is going to be. And that endpoint is going to be where the intersection of this radius is going to be, link number 3. So I'm going to do that same circle radius. I'm going to select the endpoint. I'm going to do it intentionally so I know it's there. And now this radius is going to be 4.9. That's the radius on the drawing. So that means where these two intersect, that's going to be point C. Go back over here. Point C right there. That's where we did the intersection of those 2 arcs. Okay. So now I'm simply going to draw a line from that endpoint to that intersection. And there we go. And then now I can get rid of those 2 circles. I just erase them. Enter is erase, or you can use the erase up here. And then I'm going to do one more line. from that endpoint back to the center is going to be our link number 4. So let's go back underneath. I did my link number 2, 3, and 4. Okay, I will add the pin connections for each and the labels in just a bit. I just want to get this in place. Now, the next link that we have is going to be our slider and the connecting link to that. So here you're going to notice from the center of D, vertically up, we are going to have 0.8 inches is going to be the center of that slider. So let's go back to AutoCAD. All right, I'm going to bring my slider in. So I'm going to move M, enter. I'm going to, whoopsie. M, enter. I'm going to put a box around each one here, and I'm just going to kind of move this into position here. Now, I don't know horizontally where this is going to be. I only know vertically where it's going to be. So I'm going to take a line at the intersection, the center here, and I'm going to make it kind of long. Oh my gosh, look at how on top of that I was. Then I'm going to do an offset of 0.8 inches. Right? Yeah, 0.8. And now I'm going to move my center up to there. Okay. All right. So I'm going to leave that line going through there because what this line represents is the motion, the line of action that that slider can take along there. Because if I go back underneath, again, I don't know the angle that this is at or how far over that E is from D, but I do know the length of C is 10.1. So I'm going to use, oopsie, wrong one. I'm going to use that circle radius from the center of my last point. This is going to be 10.1. So now at the intersection here is where the center of my slider needs to be. So I'm going to move my slider from this center to this intersection. And I'm just going to make sure I get the intersection. So I'm going to go like this. Intersection. There we go. And then now I can get rid of that and I can add the length of that. What was the radius of the circle? The radius of the circle is going to be the length of any one of these members. So the center from C, the radius was 10.1. And then it intersected with the line of action of that slider. Okay. All right. So any questions so far in constructing? So something that's going to come in handy a lot is that center radius when we draw these to scale. Okay. So I wanted to demonstrate this so you can see in AutoCAD how you would do that. Okay. So it's construction. And again, AutoCAD lends itself really nicely when we're in a 2D mode like this. Okay. So now what I want to do is I want to finish my diagram. So I'm going to add my labels and my, and any points of interest. I don't think there's any points of interest. I'm not seeing any on here, but we do want to add all of our labels. So I'm going to move number 1, and that's going to be one of the frames. You don't need to label both of them. You just label it once. Move number 2 to here. You don't need to put any dimensions on. So I know that they give you dimensions. You don't need to add any of those because your final answer, when you do your displacements, you'll know because I'm going to give you the final answers that you should be getting. So you will know if you do it right or not. So adding dimensions is just going to add a lot more cluttering to the diagram. So you don't need to worry about doing that. It's when you don't get the right answer, then you got to go back and you got to check what your values were. Now we do have a 5 and a 6. So I'm simply going to copy, I'm going to copy my number 4 here. I'm going to have base position there. That's going to be 5, and this is going to be 6. And then I'm just going to double click on the number 4 and put 5. And then I'm going to double click on double click on the number 4 and put 6, and then left click outside. So those are there. Now I'm going to go and I'm going to label my joints. So I'm going to move A. You got to zoom in a little bit so that you don't catch object snaps. B. C. I'm using M and my space bar just to be a little bit more quick on it. C. Move D. Okay. And then I've got to do E, which is going to be, I'll put that here, and I'm going to need an F. I'll put F out here. They didn't put it on. Oh, naughty. Okay, so this is going to be E and F. Okay. So now I need to just add my joints. So I'm going to do a copy. And I'm going to select this. I'm going to go at the center. What's nice about the copy command is I'm going to go to the endpoint here, and you can keep copying until you're done. This one's here and that one's there. So we just needed those two. Okay. So now I've got my joints in place. I can get rid of my X, Y, and my joint, and I'm good. And I'm going to do a quick save. There we go. Okay, so here is my original kinematic diagram. And again, you don't have to put the dimensions on. So you're going to notice that I kept it to just the link and the joint labels. Okay, if we put all the other stuff in there, we would add dimensions and it would just get too cluttered. Okay, so don't worry about that. And they did miss joint F. I wish they would have put it in there. Now, let's go ahead and do the mobility equation. So we did indeed, wrong one. We did indeed, you know, put all of our stuff in here. So we've got our kinematic diagram done. Now we need to do our mobility equation. So I'm going to go underneath our camera and I'm going to do, so this is example 4.1. And if you wanted to add, if you wanted to add this text to your AutoCAD drawing kinematic diagram, that's fine. Okay, that's fine. I just find I can write faster than I can type. So I know that my equation is, remember, you got to write the equation in variable form. And my equation is F is equal to 3 times n minus 1 minus 2 times JP. Okay. So I know that it's going to be 3 times n is the number of links. So if I go back to AutoCAD, the highest number that I have in a circle is number 6. So n is going to be 6 here, minus 1. And then my JP are the number of primary joints. So I've got A, which is 1, B, 2, C, 3, 4, 5, and 6 is F. That's why it's important to add that. So it's going to be minus 2 times 6. Okay. So we're going to have here F is equal to, and this is going to be 5 times 3 is 15 minus 12. That's not right. We should be getting, we should be getting 1. 1, 2, 3, 4, 5, 6. 7, minus 0, 7. Where are they getting 7 joints? 1, 2, 3, 4, 5, 6. are they getting? Hold on. There's a total of 6 joints are tallied. 1 sliding joint connects. Yeah. 6 pins. 1, 2, 3, 5. 1, 2, 1, 2, 3, 4. All right, the books, it's not uncommon that we find out that the book is wrong sometimes, but this is correct. So, so the number of links that we have is 1, 2, 3, 4, 5, 6. Okay. So that's going to be 3 times 6 minus 1, which is 5. 5 times 3 is 15. Minus 2 times the primary joints. So 1, 2, 3, 4, 5, 6. Yes. So our F, our number of degrees of freedom is going to be 3. Okay. And what that means is that we have to position something or we have to do 3 things in order to get it to do its final. Maybe the F is added, doesn't need to be there. I don't know, since the book does have the calculation. It's in the first thing there, but for some reason they have, if we look at the book, they have the number of joints being 7 instead of 6. There are no higher order joints, and that's equal to 0, right? So I'm not sure why they put 7 down here. It's a mistake. It's a mistake because there are no higher order. This should be 6. So yeah, and it happens in textbooks. So our F is 6 here. I'm okay with that. It just means that we can't just move one thing and it's going to go. That doesn't mean that it's a bad mechanism, but we are going to now move our driver and then see how everything else is affected. So I'm going to go back over here. And we want to move our driver 30 degrees counterclockwise. Okay, counterclockwise. So that means that we are going to take this one right here. Number 2 is our driver, and we're going to rotate it back 30 degrees. So I'm going to go up into the modify and we're going to rotate. And now we'll be able to leave a copy behind, but we'll have to watch our command line. So the command line is telling us to select our object. We want to select this one right here. And then we're just going to hit enter because we're just going to be rotating this one. Specify the base point. This is going to be your center of rotation. So we're going to go shift right mouse button. I'm going to do the center right here where A is. And now I have my member rotating. Now it's going to ask you down here, this is where we want to put in C. It says specify the angle, or do you want to copy? We're going to put in or key in C, enter. That means it's going to leave behind what I had originally, and it's going to put a new copy for what I'm going to rotate. If you don't do the C, enter, you're going to rotate and there's going to be nothing left behind. You're going to rotate that item. But we want to leave a copy behind. Now the angle is going to be 30 degrees. Now, remember back in AutoCAD that positive angles are in a counterclockwise direction, which is the direction we want to go in. If you want to go in a clockwise direction, you have to put a negative in front. Okay, but we're not. We're going to go counterclockwise, so it's just going to be 30 and then enter. And there's our new position. I am going to move my 2 over here. Okay. Now, what I want to do is I want to signify that this is my new position. So I'm going to click on it and I'm going to put it on object 2. And that is going to then be the new line style for my moved position of that crank. Okay. All right. So now the next thing that we're going to do is I'm going to change my layer to object 2. And I'm going to strike an arc, okay, for the path of point C. So to do that, I'm simply going to go on my circle command. My center is going to be at the intersection. No, not the intersection. I want it at the center. There we go. The center. I think I lost it. Doesn't like when you put more than one. I want to be at the center. There we go. And then it's going to be to the endpoint here, or the center, whichever one you want to do, the endpoint of this line or the center of that joint. This is the path that point C is going to take. Now, to find where point C ends up along on there, C prime, which is going to be the new position, it's going to we're going to have to strike an arc the length of member 3. So if we go back underneath, number 3 is 4.9 inches long. So from the new position of B, we're going to strike an arc that's going to be 4.9 inches long. So I'm going to circle radius. Its center is going to be on this endpoint, and its radius is going to be 4.9. Now, notice that these two circles intersected, right? That's the new position of C prime. So from the endpoint, I'm going to draw a line from the endpoint here to, now you're going to have to zoom in kind of far because you want to find the intersection. Now it happens to be it's not going across, but that's okay. We should be able to still find an intersection right there. Do not grab this one where the white is going across. You want to grab where the hidden lines would be, okay? And click right there, all right? Now that is going to be the new position, the endpoint where C prime is going to be. And then from that intersection, this one right here, back to the center of rotation at D is going to be the placement of link number 4, the new place of link number 4. So this is link number 4. So now I can erase this circle and this circle. And that's my new position of 3 and 4. So we are now going to copy B over here. And this is going to be B prime. There we go. And then here, copy C. This, I might go into here, or I'll go here. This is going to be C prime. Okay, or a little apostrophe if you would there. What was the radius of the circle? I don't know which circle you're referring to because there was 2 that I drew. They would be, the radius would be either this length if you want to find the length of 3, or the length of number 4, which is 3.3. I'm not sure which one you mean. All right, so those are coming from the diagrams. So this is the start of the new position. Now what we want to do is we want to find where our slider is going to pull back to, okay? So we want to put on the line of action of that slider. So I'm going to keep this on object 2, and we're going to draw a line. And that line is going to go through the center. And I want to make that orthographic again, okay? Let's see, zoom out. And I am going to just draw this a random horizontal length, okay? Because that is the constraint for the line of action of that slider, okay? So now, since we know the length of member number 5, that is going to be 10.1, okay? We're going to draw a circle again. Back to AutoCAD. The center is going to go from the center of C prime, and its radius is going to be 10.1. There we go. And now that intersection of our line of action for our slider and the radius of 10.1 is going to be the new position of our slider. So I'm going to move F over here. And we are going to copy our slider from center position here to the intersection right there, okay? And we are going to move my E. Come on. E. Okay. And then I'm also going to change the line type or the layer to object 2 for my new position of my slider. And then I got to change E to E prime. There we go. Okay. And then I can get rid of this radius and I can get rid of this line of action. Okay. And now I want to draw my line from the intersection of C prime to the center of my slider. And I just want to double check that I did get to that intersection. Okay, so these are our new positions. The last thing that I need to add are the joints on the new position. So I'm going to copy because these are primary joints. We want to put those where they're supposed to be. So there's that one. I think just this one. Now, as far as the other labels in terms of the links, I don't think they need to be on both times, but you do want to always put the endpoints. So the joint designations to be their regular letter and then prime for the new position. You will notice that A and D do not have a prime because they don't move. They're the frame. The ones that moved were on the endpoints. So C and B, those moved. E moved because that slider moved, but F, that remains the same because that's going to be the connection between the slider and the surface. Okay. Now, ultimately, what we want to know is when we move our length, our 30 or our link, our crank 30 degrees counterclockwise, like we did here, what happens to the other links? So we want to see, okay, what was the angle that this moved through and what was the distance that our slider moved back? So we're going to add these dimensions. So the first one that we're going to add is going to be the angles. So I'm going to go to angular dimension. I'm going to go from the original position to the new position. And this is my angle. Now, something I realize is I am on my object 2 layer. I want to put this on the notes layer. So change that to notes, and all you have to do is select it and then change the layer, but then put the active layer as notes. Because then we're going to add another angle right here, because this is an angular displacement. Because of the fact that we had a fixed center for one side, and then the other, the C, worked through or along a path, a radius, it's going to be an angular displacement. But our slider, because it is restricted to linear motion only, it is going to have a linear dimension. So we're going to go from the original position here to here, and this is going to be the value that it moved. Okay. So if we take a look, and I'm going to do a file save here. If we take a look at the illustration, this was our original. We moved our crank 30 degrees counterclockwise, and then we moved all of our elements into their new position. And then this is, if you would, the final. Okay. Notice that our output over here, they have a displacement of 0.9544. I think that's exactly what we got. Yep, 0.9544. And then 26 degrees over here. And if we look underneath, they got 26 degrees as well. Okay, so when we do this in AutoCAD, as opposed to manually drawing it out, we're going to get very, very accurate results. Okay. All right, so I'm going to do a zoom extents. I'll leave this up here for a little bit for you guys. So if anybody needs to, copy this or write this down, or if you have any questions let me know. I'm gonna pause our recording for a little bit. Okay, so the next problem that we're gonna look at is gonna be 4.2. 4.2 is a compound lever snips as shown. They're often used to like tin snips is sometimes what they're referred to. What we want to do is using the top handle as the frame. Okay, so it's telling us where the frame member is. Graphically reposition the components of the snip when the jaw is open 15 degrees. So the jaw is over here. Determine the resulting displacement of the lower handle. So this is another one of those where we want to figure out, okay, if we want this to open up from being closed, if we want it to open up 15 degrees to get something in there, what is the resulting, angle that this is going to go through to probably see if it's going to be something that we're going to be able to, handle with our hands. So what we're going to do is we've got some dimensions here, okay, for the placement of, the different elements, but might as well go right up here. This is the kinematic diagram that we're going to use and create in AutoCAD. So this is going to represent, this is the frame member. So this top part here is the frame. Oopsie, top part here is the frame. So there's going to be a connection to the frame right here. And then there's a connection to the frame right there. All right. Then we are going to have the, am I right on that? No, the frame is here. It's this one. Sorry, here and here are the frame members. This is point C up at the top. Okay, got it. Got it. This is frame. This is frame. This would be point C. So if we look up here, frame, point C. Okay. And then out here, okay, is going to be that point X. Okay, that's going to be a point of interest. All right. And then point B is going to be down here. So this is A, B, C, and D. So what I'm going to do is between those two, I want you guys to draw the kinematic diagram in AutoCAD because we'll do that same thing that we did last time, making sure that we get the same results as the book comes up with, because then we know it's correct. So we're going to go here. I pulled up my start file. I saved it as example 4.2. And I am going to start by putting my frame members in position. So I've got this one, and they're going to be 2.3 apart. So I need to copy from my base position here, and I should be able to put in at negative 2.3. There we go. Did it do it? At negative 2.3. I don't know what I'm doing wrong. Then I guess what I'm gonna have to do is construct it. So I'm gonna put a line from the center here, and I'll offset at 2.3. And I want this to go from here to here. And then I'm just gonna copy this over here. Should have been able to do that. Center to endpoint. There we go. All right, there's always more than one way to do things. So those are my two frames. Okay, so this one on the right is going to be A, the one on the left is going to be D. Okay. Then what I need to do I know? Okay. So I know that we look at this position right here. Point C is right here. So this is C, this is D. We know that the distance up from D to C is 1.5, and the distance over is 1.6. So we're going to find point C, 1.6 over and 1.5 up. So we will construct that as well. Okay. So I am going to draw a line here. I'll do an offset 1.5. This line up. And then from here, line from there to there. I want that to be 1.6 here to there. And then I'm going to change this to my object line. I should start my file like that. I might change it. There we go. And that's going to be point C. So it is 1.5 up and 1.6 over. Okay. So then I can get rid of my construction lines, and that's going to be point C. So I'm going to, that is a joint. That is a joint. So I'm going to copy my joint from here, and I'm going to put it at the endpoint there. That way it's on. So that is my point C. Now we're going to go vertically down to point B. So I'm going to put B over here. And from D, that is 1.2 down. I should have left that line in there. So I'm going to go back. Actually, we could go from C and just go straight down, and it's going to be 1.5 plus 1.2. So that'll be 2.7. That'll be the better way to do it. So I'm just going to do a line from the center here, and I'm going to go vertically down 2.7, 1.5 plus 1.2. Okay, so that is there. And then I'm going to do a copy there, and that's going to be my next joint. If we look back at the illustration, you're going to notice here's B. It's going to be connected here up to our first frame member, which is A. So they're going from B, see B, to A. So we're going to connect those two, and then we're going to have a horizontal line out and then connecting back to B. The length of this horizontal line, we don't know. They didn't add it. So just make it, again, proportional so that we have it. I wish they would have put it in there. So this line is going to go from there to the center here. Then we have a horizontal line going out to be like the end of the snips. And then we're going to go back to endpoint here. Let's add some of these letters so we can see where things go. So I'm going to move A. It's going to go here. I'm going to move B. That's going to go here. I'm going to move C. It's going to go up here. And we'll move D. That's going to go there. Oops. Now, whether you put the frame up or down, they have it going up, doesn't matter. Maybe it's more out of the way if we do that, but I tend to leave it just in the orientation we see here. All right, and then we'll move X because they're calling this endpoint X. Now let's relook. Okay, so we kind of have this side done. We need to show the handle here. Okay, so we're going to go from C down to Y and then over here back to D. And again, they're not giving us any dimensions in either place. So we're just going to kind of eyeball this. Okay, so line that endpoint a little bit below D, that, and then center. There we go. And then that is going to be point Y. So that's like where your shears are, right? And then we will add and move our link labels. So I'm going to move 1 by the frame, 2 should be that one, and it is. 3 is going to be the connecting rod. I'm going to put it like here. And then 4 is going to be that, the scissor handle, if you would. or the shear handle. There we go. Now, I think we have all of our primary joints, so we're getting rid of that, and we're not going to have a slider. So this is our finished kinematic diagram in its home position. In its home position. Does anybody have any questions on this? Okay. Not seeing anything in the chat box. Okay, so then what we want to do, we'll go back underneath. It wants us to open up the jaw. The jaw's over here, 15 degrees, and then we want to see what the resulting angle is that goes. So we're going to go back over here. So we are going to take this link right here. I'm sorry. We're going to take this link in its original position, and we're going to tip it up right here 15 degrees so that it opens up 15 degrees. And then we see that same angle. They have it labeled down here rather than up here. But to me, this makes more sense because that's opening up the jaw 15 degrees from its closed position. Okay. So the gray is the new position. The blue is the old position. And then what we're going to do is we're going to find out how this changes over here. So our input this time is actually at the jaw area. And our output is going to be what happens over on the handle. Okay. All right. So we're going to do that. We're going to duplicate that in AutoCAD here. All right. So we want to take our link number 2 and we want to rotate it 15 degrees. Now this link is going to rotate about point A. That's its fixed position. So if we want to rotate, copy this, okay, we got to take a process here. We got to watch our command line. So we're going to go up to rotate and it asks us to select the items. So we're going to select all of the items and we're even going to grab the X, not the number 2. Okay. But we will do B. We will do this link right here, or I'm sorry, the joints, this link, and that should be good because we're going to rotate about A. That's going to be our base position. Okay, so those are our selected items. It looks like I did 1, 2, 3, 4, I don't know, 5, 6, 7-ish. And I'm going to hit enter. Now it's going to ask me for my base position. This is where things are going to rotate around. My base position is going to be the center where A is here, right there. Okay, that's my base position. Okay. Now, don't click anything. Don't put 15 in yet. You need to hit C, enter here because we want to leave a copy. We don't want to redraw. So C, enter. So that means it's going to leave a copy behind. And now we're going to specify our angle of 15 degrees. It's counterclockwise is positive. If we want it to be negative, it would be negative. So there it is. Now what we want to do is we want to select each one of these, left click these, okay, including, maybe not their joints, just the lines, The joints can stay, otherwise it'll look kind of weird. Okay, and we want to put those on the object 2. Okay, because this is our new position. I'm also, looks like number 2 is not in a great spot here. So I think I'm going to put it just right down below there. There we go. Okay. So that is the new position for our snips. I'm going to go to notes and we're going to add an angle to this, an angle dimension. Oh, I didn't go to the right one. That's why. Wait. Oh, it does look bigger than 15. I wonder what happened. Hold on. Angular. Oops. Angular from here to here. Oh, there it is. 15 degrees. Whew, good. Sounds like I think I put it in correctly. Okay, so we opened it up 15 degrees. So you want to go from the corresponding flat and flat there. Okay, I went off of the wrong ones. That's why it was larger. Alrighty, so now we need to catch the other stuff up over here. Okay, so just like we did last time, we are going to, this is our B prime now. We're going to double click on that. This is B prime. This is the new position for B. And what we need to do is we need to find, okay, if B is here, that's going to pull C along. So we're going to change to object 2. We're going to draw a circle radius with its center at its center of rotation and the radius right there. So C can only move along that path there. So now from B prime, we want to make another circle, a radius equal to the length of that link. Okay. The length of that link we didn't get. So what we need to do is we need to measure it. So we are going to, oh, wait, is there another way to do this? I think I can do distance if I'm remembering correctly. Hold on. Let me try this for a sec. Distance. Okay. I think I can. Oh, I guess not. I missed that. Maybe I'm remembering it from a different program. We are just going to do this. We're going to add a dimension for the length from here to here. Oh, I did know that. It was 2.7 because we did the 1.5 plus the 1.2. Sorry, I forgot about that. So then we're going to do a circle with the radius of 2.7. There we go. And now we want to find where those two radiuses intersected, and that's right here, okay? So now we are simply going to do a line from the endpoint of B here, right there, the B prime, and to the new position, which will be C prime, right there, the intersection of the two circles. So I'll let you guys look at that first, make sure that you've got it. So this is the path of C, and then the radius of link number 3, which is 2.7, is going to be this circle. So now I can get rid of those two because we just used it for construction. Oopsie. And now from that new position of C, we're going to go back. Wait. There was C. We got to go back from, see here, my line from C to the center of D. So I can copy the C to here, and this is C prime. And then B, because that kind of got in the way. B is going to go there. And then B prime is there. Right. And then what we need to do is we need to rotate this to the new position. So to do that, we're going to do that very same thing that we did before, but we need to find what is the angle that we're going to rotate this to. So we are going to put on the angle command. We're going to measure between here and here. And it looks like it's 34, but I have a feeling it might not be exactly 34. That would be rounding. Let's try to get something more exact. So we're going to go into, I think it's this one, dimension style. So you're going to hit, if you have it, you're going to hit the annotate, and you're going to go to dimension style right here, the second one down, and our dialog box is going to come up. And we're going to go into modify. And we have our primary units. And we want to find where the angle is. Angle dimensions are right here down underneath. So primary units tab, angle dimensions, decimal degrees, and we want the precision, I'm going to say, to 3 decimal places. And I'm adding that just because that way when we enter the angle that we want to rotate and copy, it's going to be more accurate. Okay, so 3 decimal places for your angle. Again, this is layout. This wouldn't be something that we would do if we were to, you know, release this for production. We wouldn't do this to 3 decimal places. We just want to use it for construction. So I'm going to go back and I am going to get that angle in there from here to here. Sure enough, it was 34.363. So that's the angle that we want to rotate. Link number 4, we want to rotate, copy it to its new position. Okay. So as we look here, we are going to rotate. So up in the modify area, I am not going to select this line because this one we already have in place because it's the new position here. So we're going to do this one, our joint, this one, and I think that's it. And oh, we can do Y as well, because that's going to be a new position. We already put C prime where it goes. Okay. So just those, don't do this one. All right. Because we already rotated that. It's already there if you would, or I already drew it in position. So now I can hit enter. And now it's asking us to specify the base point. This is going to be the point that it rotates around, which is going to be point D here, the center. And now what we're going to do is we're going to rotate this. We're going to rotate copy. So we need to hit C here. Watch your command line. And then the angle that we're going to rotate it at is going to be that 34.363. 34.363. And it's a positive value because it's going counterclockwise. There we go. So there's the new position. And then all I need to do is I need to change this one and that one to be the object 2. Okay. And there you have it. Now we needed to measure what the angle was that this opened up. So we are going to add the angle from here to here. And it says 34.36 degrees, which would make sense. That's how much we did rotate it. And that happens to be the answer in the book as well. So I'm going to leave this up here for a second. Okay. And the parts of this that are important are going to be the 15 degrees, the new positions of all of our links in a new line type and color, and then the new labels for where things move. So like anything that has a prime on it. Okay. I'm going to do a file save on this. And this would be your screenshot for example 4.2. Make sure you add that as a note here so you know that that's what that one is. Okay. So this opens up almost 34, almost 35 degrees, between 34 and 35 degrees when our jaw opens up 15. So again, it gives you an idea if your hands, if you would, are big enough in order to do that work. Questions on this example? Okay. I don't see anything right now. Now, as I'm looking at the time that we have, these do take a little bit when we're drawing them here in AutoCAD. As we move forward, actually, this is going to be where we end today, just so that you know. As we move forward in other examples, we've kind of gone, you know, and done quite a bit of CAD work here, which I'm hoping gives you some really good practice as you start looking at the actual homework problems, and you'll be able to use what we learned here to translate. So, so what I'm going to do is I am going to kind of stop there. If you wanted to look ahead at some of the problems, you can. But I think, you know, you're going to benefit from the extra practice that we're going to do on Monday in order to, you know, feel more comfortable about that. So, so this is exactly where I wanted to be today, because the next time we get together, we're going to be talking about limiting positions and stroke. And then we're also going to be doing displacement diagrams. Okay. So, so that's all that I have for today. So, so hopefully you found that helpful. I'm going to stop recording.